So hello guys, I hope you are doing well. So here is the question we have jump game 2. What the question says, you are given a zero index array of integer nums of length n. You are initially positioned at index 0. Each element nums I represents the maximum length of a forward jump from index I. So what this line says to you is, suppose this is our array. So again we have this, suppose initially we have starting with an index 0 and we want to reach the index number 4, or we can say index last index. So from the starting of the array we want to reach the last of the array, or the end of the array. So what are the minimum number of jumps we require to reach from the start to end? Element num size represent the maximum length of a forward jump. In other words, if you are at index I, you can jump any index I plus j, where j is greater than 0 or less than equal to sign, and I plus j should be less than. And return the minimum number of jumps to reach index n minus 1. The test cases are generated such that you can reach index n minus 1. So we can assume that we can always reach n minus 1 to index. So we can write the code for this. The constraint are the 10 raised to the power 4, which means that we can solve it by big O of n or big O of n log n. So we can solve it by big O of n here. So what are the approach for it? So see, here we are. So we can take a maximum range. So here we follow a 2-pointer BD approach, where we should track of the range where we can jump. That is what are the minimum jump and the maximum jump we can reach. Suppose here, suppose we are at the ith one, and we can reach kth jump from here. So we can jump 0 or the kth maximum. So from every point we can track of the farthest element or the farthest jump we can take from the index I. And from every window from this index I to the farthest point, we can again calibrate the farthest point set in this particular window where I can reach the maximum point. And again we keep the 2-pointer approach like this. So let's dive into the code. So here we have the size of the array first. Now we take 2 pointers, first of all, L and R. Here we start a while loop of R, which should be n minus 1. And now what we take as in my farthest element, which should be 0 at initial level. Now I just keep track of the maximum element, that where I can move from to the, not 0, it will start from L and reach to R, and I just keep track of my farthest element, that where I can reach the farthest. I plus nums. Yes, so when we calculate the farthest element, then we do nothing. We just do my my L should be equal to R plus 1, and my farthest and my R should be equal to farthest, and my jumps should be plus 1. So here we should declare another variable as jump, and from the final answer we return jump. It's t if it is correct or not. Okay, we make an error here. Let's check it if it is correct or not. So if it is accepted, you can now submit it. Or yeah, it is correct here. So what the space and time complexity? So we can say that here we followed a two-pointer approach in which not a double while loop, you can see, not a here a two-pointer approach, because this will keep track of R and N and not don't do anything else uninstall. It will totally give it to big O of N. So here you can take as my time complexity should be big O of N, and space complexity and my space complexity should be O of 1. So, so this is the final solution, a greedy based two-pointer approach. So I hope you like the solution. Thanks for watching the video.